contact analysis. I don't know if you have done analysis of contact stresses. So that we will be doing that. So these two exercises I have planned for today. Let's just start. So first exercise will be the screwdriver. So we'll start with that. So first thing, change this to part design and click on create body and create sketch on XY. And we are going to use this hexagon. This, and it is the vertical. Click to end the command and give it size 6 mm. Adjust the screen. Then we'll extrude this. So this extrude is by pad command. And make sure that this is symmetric to the plane. Let's keep this length as, and click OK. And you can go to view and switch on this toggle axis so that this coordinate axis is visible. So because we did it in that way, that is symmetric to the plane, the toggle axis, the coordinate axis is located right in the center of the object. Right, so now let's create another sketch and select create sketch, select YZ plane and click OK. Right. Now for sketching this, what we are going to do, we are going to create a section. The object is divided into half so that we can see whatever construction we are doing. Now we have to sketch on this plane. Now directly I cannot sketch because I am not able to pick any reference. Okay, so I need to import some geometry from this object because it is right now it is not on the plane. So click on this icon, that is for import geometry, and make sure you click the corner so that now this dot is now on our what is it, sketching plane. Right. Now go to the polyline option and make this triangle. Right. Now when you construct this triangle, make sure that these constraints are visible. So this line should be horizontal, mutually perpendicular to each other. Right. Now as the sketch has 2 degrees of freedom, now we will give the dimensions to this triangle.
Sir, how to make the section?
What section?
Section view.
Ah, section view. See, there is this icon here where I place the mouse. Okay, so you can toggle that. See, if I toggle it off, see right now the triangle which I have sketched, that is partially visible now. Okay, so to just to make sure that our geometry is completely visible to us, you can just toggle it on and off.
Okay, sir.
Okay, and just click on this button so that it toggles off and on. So now it is sectioned. You can see the half, only half of it. Okay. When I toggle it off, it becomes a hexagon. Let's give this dimension. This is 0.8 mm. 0.8. Just set this properly. And the vertical distance, we'll keep it as 1 mm. Just drag it out so that it is visible to us properly. And now you can see it says fully constructed. Now whenever you're constructing, if these two boxes are not checked off, make sure you check it on. Okay, so that it whatever redundant constraints are there, it will remove it automatically, and your sketch will be automatically getting updated. Now after that, what we are going to do, we are going to cut this out. All right, so for that, so let's close the sketch and go to the groove option. See, this icon is there. it says groove the selected sketch. Alright. So you select this groove. Alright. So it just chamfers of that corner. Make sure you select the this axis and click OK. Okay. So this base Z axis should be selected in this option. Okay. This should be base Z axis. And click OK. So now let's go back to the model. And now in the model you can see this groove is created. And if you want to see the sketch, you can toggle it on and off and you can see the sketch. Now I want the same feature on the lower part also. So what I'm going to do is there is this option, select the groove, whatever feature you want to have on the both side, on the top as well as the bottom face, select that. So here you will see that it is selected in the window, it is selected as the groove. Okay. And it should say transformation succeeded. Now you have to select the correct plane and you have to select the XY plane. The moment you select the correct plane, the feature which is at the top is also repeated at the bottom. Okay. And then click OK. Right. So this mirror feature is available on the top and the bottom. I'll just come back in a minute. Get some water. All right. So everybody on the same page up till now. Now we'll create the crown on the top of this. So again, go to create sketch, and select the YZ plane and click OK. All right. Now again we need some reference to create this geometry. So again we are going to go to this import geometry option and select on the top edge. All right. So that we have this reference points to construct the next sketch. Okay. Right, so we are going to use these points which are just generated to create the sketch, and so we are going to, you can again do the section so that the half of the object is visible, whatever construction you are doing is visible. Okay, select on the polyline option and just go on creating this polyline. Okay, so the cover is closed. Right, so if some undesired features are created during the sketching, you can fix them by giving the if this line is inclined, select this line and select this horizontal constraint option, so that will make it what you say, horizontal. And if you see the remaining sketch, this now this line is horizontal and this lines are constrained in vertical direction. This symbol that these lines are constrained in vertical direction, so no need to do any constraining on these two lines. Let's check this. So this is also constraint. Alright. Now let's give some dimension to this. Okay, so make this and make this 5 and take top and bottom and make this as 10. No, wait. Pick the correct point, this and this one, and then make it 10. Right, and this is 10, this is 5, and this one make it as 0.35 and click OK. Right. Just move this. Everybody got this one?
Yes, sir.
If you are stuck anywhere, just let me know immediately. Yeah? Otherwise, I will keep on doing, and then it should not happen that there is a mismatch. Okay. So now you can see that the entire geometry is fully constrained. Okay, and you can just so whatever thing we have imported, that you can delete it because we don't want it, and just close it. Just click on revolve. Okay, so and select the vertical Z axis. Right, and click OK. Right, so this is the latest step that we have done, that is a revolution. Right, now we need to add some more details to this geometry. So we need to cut some grooves on this, so we'll do that. So for that we need to create a what you say, in addition to the plane which you have, you can create a datum plane. All right, so let's do that. Select this point and do a control and select this edge. Click on the datum plane option. Okay, so this window will open. Right. Okay, so this was the
Sir, how to rotate the body?
just click the shift key, sorry, press the shift key and use the right click of the press the right click simultaneously of the mouse.
Okay, sir.
Shift and right click.
So what did you do for this plane?
Okay, so we delete this again. Okay, so just zoom in on this, and I want this point. I want to pick this point. So pick the point, then zoom out and hit the press the control key. So for multiple selection, you have to use this control key. Okay, so press the control key and select the edge. So you can see both the point and this edge both are green. Okay, so both are selected. After you select, click on the datum plane option. Okay, so a datum plane is created through this. Okay, now we want to create a datum plane which is normal to this. So if you just click on this various option, there are various options. If I click here, then it becomes it goes to the top, but I want it in a vertical plane. So I will click on OYN. Okay, align in that OYN direction. Right. Okay, so it is now perpendicular to the initial position which I had selected. Okay, it is perpendicular to the initial position I have selected, and just click OK. Okay, now we are going to sketch on this datum plane. Okay, so to sketch on this datum plane, what you are going to do? Select this plane. Select this plane and click on the sketch icon. Okay. All right. Everybody with me on this up till now?
Yes, sir. Yes.
All right. Now we are going to cut some grooves in this geometry, just like the actual screwdriver. So again, we are going to use the polyline option. Okay. So select the polyline option, and now you need to. So now, if the datum plane is creating any clutter, you can go to model and just switch off the datum plane. Okay, so as we don't need the datum plane, we are already sketching on the datum plane. Once we set it, you can uh, remove it. Okay, so select this, draw this, construct this polyline and construct it in a similar manner. So just make sure some part is vertical. Right, after that, after you make it vertical, then use the toggle key M till you get the arc, and approximately make sure that your arc is like it is a quarter circle. Okay, so that your geometry doesn't go haywire. Right. So click and then again click on the M option till you get this vertical line. and make sure you have the constraint, vertical direction constraint appearing, so that it becomes a vertical straight line, and then just close this curve. Alright, now we are going to give some, everybody got this? You want me to repeat this?
Yes,
Everybody got it?
yes.
Repeat.
Oh, if you want something to be repeated, then you just tell me immediately. Yeah? Alright, now we'll give some dimension to this. So let's start by this and make this as 1 millimeter. Okay. And if it shifts, then give this radius as 14 millimeter. Alright, and distance of this corner from the axis, horizontal distance, let's make it 0.35. Earlier it was 0.35. Right, and also make this, select this two and select this perpendicular option. Okay, all right. The task option, it is fully constrained. Okay, and you can close the curve.
What are the dimensions?
Wait just a minute. We'll just place the dimensions properly. One. All right, can you see it now?
Yes.
Okay. After giving the dimension, you make sure that you select this curve and this vertical line and click on the perpendicular constraint. Done up till this? Can I go to the next step? Alright, so now after that, after you done sketching done with the sketching, just close this, right, and select this option that creates a pocket. Right. And this is 5 mm, so keep that as it is because we want it 5 mm, and click OK. Right. So you can see that this cut is created. Now I want this feature to be repeated, so repeated 4 times. All right, so for that, what I'm going to do, I'm going to create a polar pattern. Click on this. Now by default it says 2, so if I just So if I just select the correct axis, it is this axis. Right. So since it is 2 here, you can see the second pocket is also getting created. Right. But for our model, we need, instead of 2, we need 4. So change this 2 to 4. Right. So the 4 pockets are getting created. Okay. And then just click on OK. See the top, this 4 are created. And just make sure that the entire object is visible. Just do a right click and click on fit all. Everybody is able to do this?
Yes, sir.
Okay. Now next part is slightly tricky. Now what we are going to do is we are going to use this small triangle which is created as our sketch plane, and we are going to create this groove on the other side also. Select this triangle and select sketch on plane. Okay, now we'll again need to import geometry. So just on this object a little bit, and we want the end of this line. Okay, and make sure that you get this dot over here.
So what did you do now?
Just click on the import geometry icon and go to this end of the line and click at the end of the line. That red dot should appear. Okay. Everybody got that? And again click on the sketch icon. And go to polyline. Go to the polyline option. Right click to end this command. Go to the polyline option and again do a similar construction. Do it again. Here sketch plane, import constraint. Okay, dot. Then create the polyline by starting, select the polyline option and make sure that you start it close to this vertical point and you join with this point, and it should be a vertical constraint. Right? Then change it to curve. Make sure it is almost like a quarter circle. If it is not like a quarter circle, doesn't matter. We can change, always change it. Again, click on M. Vertical line. This is vertical. Join with this. Right. You can select the section option again to see the sketch. Right now the sketch is not complete constrained, so you can adjust the sketch approximately to where we want it. And cue this radius as here as 14. Okay. And then make this curve and this vertical line perpendicular. Right? Okay. So our sketch is set, and we are going to create now another pocket. Everybody's got this?
So can you wait 1 minute?
Yes.
So can you repeat this sketch?
Okay. Just let me close this. We delete the sketch. Okay. Now select this small triangle and click sketch on plane. Now I need some reference, so I'm going to do import geometry and click here, and I will get the dot. Right click and end it. Okay. And again click on the sketch option, and then select the polyline and make sure that your vertical line is somewhat aligned to this. Software will automatically align and make it vertical. Right. All right. After that, change this to circle. Keep on hitting the keys till you get the circle. Once you get the circle or the quarter circle, approximately make it as a quarter circle. Click, then again change it till you get the straight line, and make sure that the straight line is more or less vertical, and then just close this line. Okay. So now if you are if you sketch it properly, some of the constraints are automatically generated. Like this is horizontal, this is vertical, this is what we want. If you are not getting this as horizontal and vertical, just click on this line and make the constraint, and click on this icon. It will make it horizontal. select this vertical line, click on this icon, and it will make it vertical. Okay, and now now you can also see, if you want to see the sketch as you do it, just select the sketch option so that the sketch will be visible to you. Okay. So make sure the sketch is all connected. Make this portion above this and change this radius. Let's make it proper. And select this, change this radius to 14. Right, so if this goes down, just select this and this line and select the perpendicular option. Right, so move around this. Right, so if we can see, the sketch is now exactly coincide with our earlier groove. Alright, so we are going to use this to cut the groove in the opposite side. Alright, so close the sketch and select the pocket option, and select it reversed. See the groove being made, it is like a symmetrical, and keep this as 5 mm. Make sure you select it reverse so that it cuts in the other direction, and click OK. Right. You can see now only one groove is cut. So the groove is cut on both sides now. Can you observe that? The other grooves are cut only half on one side. Right. Only one groove is cut on the both sides. So we again want to repeat this pattern. Alright, so again we are going to use the polar pattern option. Alright, so select this, just close this window so that more space we get. Select this pocket option and select the polar option again. Okay, so this pocket one, that is the feature which has been created. Select the Z axis, base Z axis. So as soon as you select the base Z axis, you can see that there are two such pockets cut on either side, 1 and 2. Alright, so we want it on the all the 4 grooves, right? So just change this 2 to 4 and click OK. Alright, so grooves are cut on both the sides. Everybody got this? Can I continue?
Yes, sir.
Anybody who is not up to the pace, let me know. Okay, so you can observe this object. So as you can see, very complex geometries can be created very easily. We are going to add few more features to this. All right. So again, a few more features we are going to add. So create sketch on plane, select the YZ plane and click OK. Right, and do a section. So here we are going to construct the feature over here. Alright, now I want to select the center point. Alright, so if I want to select the center point, I go to import geometry, but now it is not allowing me to select that center point. Okay, so what I am going to do, close this. So I need that center point. So there is this option called as create a datum point. So select on that. So select this plane first and click on this datum point. So as you can see, a dot is created at the center. Alright, and it is actually at the center of the mass. Everybody got this?
Yes.
Okay, and just click OK. And then let's go to the our sketch. Right. And you can do a section and you should see the dot. Right. So we are going to use that dot which you have just created to what you say, to the sketching, and again you have to import that. So import geometry and just select this dot. Okay, so now it is available on our sketching plane. Right, now again select the where is that sketch option, and then again select the polyline option and select this horizontal, vertical, and again this incline and this dot. And close this curve and make this angle as 75 degrees. Not this one. Make this angle with the vertical as 75. Click OK.
So how did you add that angle?
Okay. Okay, you created the polyline. Just select this vertical line and this, and click on this angle sign, fixed angle, the one below the circle. Got it? You want to do it again?
No, done.
Let's All right, there was a power failure. All right, can everybody see the screen now? Hello.
Yes, sir. It's visible.
It was a power failure. That's why it got disconnected. Okay, so just draw this. I will just do this step again. Just delete this. So go to this polyline option. Select anywhere on. Select this dot. Go horizontal. Make sure it is horizontally constrained. Then vertically constrained. Then incline, and then close the curve. Alright. Then select the vertical line and the inclined line, and select this angle and make this 75 degrees and click OK. Alright. And then select on this line and make this distance as 0.5 and click OK. Alright. After that, close this curve and select this groove option, and it says 360 degree, and select OK. You can see the sort of chamfer is given on the tip. Everybody got this? Alright, so last feature we are going to give, select this option, select the YZ plane and click OK. And now we are going to cut this a sort of, what is it, a small sort of groove that is meant for attachment. We are going to do that by cutting a triangle. So what you do, import constraint and select this vertical line so that you can get some reference, and select this polyline option and do the section and just construct a small triangle. Alright, and add another constraint. Select these two lines on the triangle, 1 and 2, and make it equal. Correct? Then make this angle between these two lines as 120 degrees. Click OK. And also make this distance as 0.25. So our sketch is set. Now we'll do again the glue option. So close this sketch and select the glue option, and it says 360 degrees. Select here the vertical axis and click OK. right? So that completes our group. This datum point which is remaining, you can just switch it off by pressing the tab. So this is the complete model of the screwdriver tip. Alright, so that is the first part of today's tutorial. Everybody got this? How many of you are able to do this? Can you raise your hand in the chat box? How many of you are able to complete this exercise? Only 9 students. So rest of them are not able to do this. How much is the count? 35, I guess. 35. Alright, any questions? Before we start with the next part. Let's save this file. Save as. My power is back.
So what was the dimension of the last groove?
Yes, please, sir.
Yes, I forgot. Yeah, I did. I was just disconnecting because our power is on. Somebody was saying something. Yes, please, something. I didn't hear that. So can we start with the next part?
Sir, he was asking for the dimension of last groove.
Last groove, the triangle. Just open it.
Sir, can you upload the CAD dimensions of the file?
Yes, yes. I will do it after the what you say, the at the end of the session. I will do it so that if you want to practice it, you can do it. Right, so these are the dimensions of the groove. This is 25 and angle is 120 degrees. Okay. Angle is 120 degrees. and it is a these two sides are equal. Is that what you are asking?
Yes, sir.
I will give all the dimensions at the end of the session, so that somebody who is left behind, and you also will have the video, so you can practice the model. So how many of you are familiar with other softwares like SolidWorks or any other software? So have you tried to like make such geometries in SolidWorks?
Not yet, sir.
Okay. Anybody who is when I use SolidWorks, I found compared to that, this was much more proficient. I mean, you can do things very easily and intuitively in this. Anybody has any different opinion or something like that?
So I
Sir,
feel SolidWorks is more user friendly than this one.
yes, sir, also using it for long period of like we have been using it since a year and a half, so we are very
Ah,
well
yeah. So
versed in it.
yeah, no.
So
So
it
you
becomes
are
better at that point.
yeah, like this needs a little bit more practice. I am like no not a what you say. SolidWorks has some features. This software also has some features. The main feature is that personally for teaching, it is a open source software. So no, I can ask the students to install it very easily, and also there are no things such as piracy and all those things. Those are avoided. So from ethical point of view also, and once you get a hang of this software, you will find that this is very easy. No, the interface might be slightly different from
Sir, it
SolidWorks.
is little complex.
It is complex. It takes a little bit of getting used to. But once you do few exercises, then you will find that this is very easy. And I don't think so, SolidWorks you can do FEA, right?
We can do, I guess.
Okay.
Sir, the features are very limited.
FEA features. FEA is very limited in SolidWorks.
Yes, sir.
Yeah. So here you can find that this is like lot of very good analysis you can do. You can control the mesh properly. Okay. Now I don't know if you have done. So let's go to the next exercise. I don't know if you have done this kind of analysis in any software. So what we are going to do is the contact analysis between two objects. So let's change this to part design, and just let's start by sketching the geometry. So tasks, create a body, create sketch, create it on XY plane, and click OK. Once you see the the more attractive thing about it is the way this software does FEA. It is very intuitive, like if you imagine that how I should give some constraint or how I should apply some force, and if you imagine that okay, I want to do it this way, the software does it exactly that way. So that is what I found very useful from the FEA point of view. Modeling, it takes a little bit of time to getting used to, but once you get a hang of it, then you will find, because that you can easily create very complex geometry. All right, so let's start with the next session. So it is done the contact analysis. So let's start. Select the polyline option. Just go on constructing this geometry. click to make these two sides equal, right? So they are constrained to be equal. Okay. Now let's give the dimensions. This be and this as okay. Also construct a circle somewhere here. The dimension of that circle is 8 millimeters. Alright, so give the dimension as 8 millimeters and give the distance from both the axes. So this is there is another way to give this dimension, this constraint. One is you select the one point and the vertical axis. Okay, that is one way. And if your geometry is constructed using these two axes, you can just select the center point, and when you want to give the vertical constraint, just select the vertical eye, and you can just give the dimension. It is a constraint, not dimension, constraint. The right word to use. Alright. So now this is completely constrained. So let's close this. No, one more dimension is remaining. This dimension to give. So that is. Alright. So, and I have already constrained that this and these two sides are equal. Alright. Alright. So close this sketch and then we'll just pad this. Yes, YMM. Make sure you select this symmetric to the plane option. Click OK. Now let's give some fillet on the corner, on the all the corner edges. So go on selecting this. I will just change this to wireframe so that for me to select. Go and do the fillet option. You can do it from here or here also, and change it to 8 millimeters. Click OK. go to this option and click on create body, and then create sketch and select the XY plane. And click OK. Construct this circle. Can also change this thing. And give the dimensions of this circle as 3 millimeter. Now give the distance of this circle from the horizontal axis and vertical axis. So let this be 35. Click OK. Distance of the center from the horizontal axis. Let this be 125. Click OK. Right. And close the sketch. And again go to the pad option, and symmetric to the plane, and give this distance as 300. So this symmetric option makes the object symmetrical on both the sides of the coordinate axis. So in the model you can see that there are two bodies, body 1 and this is 2. Now select this, now go to part and select this body and select on this icon, make union of shapes, and it should appear here as fusion. Alright, done up till this.
Yes, sir. Yes.
Just a minute. Alright, so next we'll go to the FEA part. So change the workbench to FEM. And then we'll now give the constraints. So first select the analysis, So that is the solver, that is the calculi X. After that, you select the material and select the calculi X steel. Select this calculi X steel. So the properties are displayed over there. That is density, Young's modulus, everything is there. So we are going to keep that as the same. We are not going to change those. And just click on OK. Okay. Now we are going to give some constraints. So go to the constraint icon. So we are going to give the displacement constraints. We are going to give various constraints here. So select this and click add. And make this X displacement as fixed. Make this as fixed and click OK. More constraints. Those are the constraint parameters. And going to do cylindrical transform. Select the curved surface and click add. So what this does, this is the axis of rotation. So this whole angle is free to rotate about this axis. Okay, so, and this is fixed. It is not allowing the object to move in x, y or x and y direction, and it is fixed to it is free to rotate about the axis, which is shown by this blue arrow.
Sir, can you repeat this step?
Okay, I just cancel. Go to this option. Just created it. Go to this option and select this curved surface. Add and click cylinder transform. Sorry, first select cylinder transform. Click this cylinder transform. Select this and click add. Right. So this is your axis of rotation, and it is fixed in x and y direction. And click OK. So the blue arrow represents the axis of rotation. So some more constraints need to be given. So again we'll give some displacement constraint. And select this face. Click on add. And select this Z displacement as fixed and click on OK. Right. So this symbol should appear. And also we'll give them displacement. So far we are given 0 displacement to all. We'll give displacement at on this edge. So again select the displacement constraint. Select on this edge. Click add, and we'll give it a displacement of -15. in the y direction. Minus 15 and click OK. Right, so this symbol appears over here in the y direction. In the y direction, this is going to give you the displacement of 15. And so now this is one rod which is in contact with this angle, and we'll see the effects of the stresses that are generated. Now we need to constrain the rod. So select the constraint option. Select these two faces. One. So click on add, and go on the other side. So, and again click on add. So both the sides are fixed. And click OK. I will also define the constraint which defines the contact between these two surfaces. So select this icon which is next to the displacement. Sorry, the last icon. This icon, the icon next to the displacement. And select this object, click on add, and select on this vertical face, click on add. You see the symbols appearing. Change the properties. This one is 21 followed by 5 zeros. That is 2100 megapascals, and friction coefficient between these two interacting surface. Let's make it as 0.1. You can see a lot of detailing has been done, and it is very much simulating the case by giving so much parameters. It is very precise in terms of when it comes to FEA part. I find that this is very precise. Okay, and click OK. Okay, so the constraints are done. Now what we'll do, we'll do the meshing. Select this. And there are two meshing options available over here. I am going to select the G mesh. And click OK. Don't click the apply immediately, click OK. And go back to analysis and see this here. And we're going to refine that mesh. we are going to refine that for this rod. So select this rod and click add. Okay, so it is added. All right, and we are going to refine this and make this as 2 millimeters. Okay, and select this face, edge, and vertex option here. And click OK. Right. Now double click on this mesh, and after that click apply. So that's going to mesh now. Alright, so meshing is done. Alright, so it doesn't give any errors, so that is good. And as you can see, the meshing was done very quickly. Okay, so once the meshing is done, just click on OK, and you can see that. You can see the mesh region over here. Toggle on and off the mesh. Okay. Now we have to solve this, and to solve this, we are going to use this calculi X. Close this window so that I can see these values. Make sure you change the initial time step to 1, otherwise it takes a really long time to solve. And you can also read the various parameters. Just expand this window a little bit. Alright, so these are the various parameters under which it is going to solve. And static analysis, geometric nonlinearity is kept as it is in this case. Right. Make sure the initial time step is 1 over here. Okay. Right, so rest of this thing we are going to keep it as it is. Now just select this calculate option and click on this icon to run the solver.
So you have to delete the constraint I.
Uh,
You have to delete the constraint I that.
oh,
Is.
Let me just. Alright, so now let's go here. Okay, so it is running. Alright, it's running now. So it's going to take some time. Has anyone done this kind of analysis, contact analysis, using any other software?
Not yet, sir.
Okay. Means somebody might be using ANSYS or similar kind of software. Seems it is done. Okay, so the solution is done. Now let's do the post processing. Let's close this windows and drag this down. So these are our result sets, and here you can do the post processing analysis. So as you can see, it gives me very good results. Okay, it shows me what happens as the two um, objects, the rod and the angle, they interact, and as the deformation takes place, how is the displacement, uh, and also then you can check for the stresses. Okay, so as you can see this red area, that is where the stresses are critical. Right, so you can just check out the various options, and if this constraints which you have given, they are creating any clutter, you can just switch them off. Okay, just select them and switch it off. You can change the factor of the slider to like whatever you want. If you want to restrict the your analysis accordingly, you can change the factor. Right. So it gives you the minimum and maximum stresses which are induced. So a lot of information you can get very easily in a very systematic manner, very easy to interpret. Now if you want to just modify the appearance, click on the fusion and increase the transparency so that it doesn't clutter your FEA results. so that now it doesn't clutter your, let's say, close this. Select this FEA. Okay. Close this. Now we'll do a little bit more precise analysis. So to you do the precise analysis, as I showed you last time, we can use the pipe option. All right. So just click on this pipe, and you can select the surface and field displacement. So it gives you the displacement. Alright, the legend is over here. You can move this over here so that you can see it properly. Okay, so here you can get the actual values, and the display is color coded. You can find the stresses. Find the one misses stresses. Right. So as you can see, the maximum stress, it is indicated in the red area. Okay. Okay. All right. Now one more option you can do is this. Since there is a lot of warping happening, so you can do that warp factor. Okay. Everybody is with me on this last part, the warp factor. So change this maximum warp to 1000, because okay, and then you can select first option, displacement. Let's see, apply. Okay. X surface displacement. All right, so in this way you can see the uh, various results. You can also modify the number of labels you have. Just click on this options. So if you want, instead of 13, maybe want more labels, you can change that. Okay, so it gives you. All right, so in this way you can get all the results very easily. I guess that's all for today. Any questions?
Sir, is there any assembly option available for farms?
Pardon?
If we have two or more parts, then do we have assembly options?
Yeah, you can do assemblies also in this. You can do assemblies in this software also. I am majorly focusing on creating, doing FE analysis and working on making complex geometry. Once you are able to make complex geometry, FEA part is very simple in this. It is quite intuitive. You can do so many things in this. Any other questions you have? You can just play around with this stuff. I guess that's it for today. Unless you have any questions.
The feedback form has been sent on WhatsApp and in the Microsoft Teams chat.
Okay, thank you very much. You have created a separate form for today, right?
Yes, sir.
Okay, okay. So I hope this was useful for you. Try the what do you say, the same exercise at home if you are not able to. How many of you are able to complete this exercise, the second one? Please raise your hand in the chat box. Okay, 32. Okay, so I will give the dimensions and all everything, so you can try it out. And I hope this was helpful. So tomorrow we'll do more complex geometry and we'll do FEA of that complex geometries. Okay, and we will also do what you say, the composite analysis of composites material. So that's all from my side for today. I think we'll stop here now. You have any questions before we end? All right. Thank you very much. I hope this was useful. Okay. Thank you. Bye.